Bismillahirrahmanirrahim. Assalamu alaikum, all friends, students, and viewers. Today, our topic is velocity time graph, and we will discuss briefly the graph between velocity and time. In previous lecture, we discussed in detail velocity, its variation, and its types. And now we will discuss velocity time graph, the graph in which velocity varies with time is called velocity time graph. The variation of velocity with respect to time which representing with the help of graph, that graph is known as velocity time graph. And the velocity is variation of velocity with different types. When sometime velocity is increases, sometime velocity decreases, sometime velocity of an object is uniformly, sometimes velocity of an object is constant. According to the condition of the variation of velocity with respect to time, we represent this variation with the help of graph, and we discuss in detail how velocity varies with time and how graph tells us about the variation of velocity and how we represent the variation of velocity with graph. Now we start the graph which give the variation of velocity of an object with time is called velocity time graph. And there are different conditions according to the variation of velocity. We discuss all the conditions and we draw the graph and we discuss in detail how velocity varies and with respect to time. First condition, case 1, when the velocity of an object is constant. When the velocity of an object is constant. When the velocity of an object is constant, it means there is no variation in velocity. Equal displacement covered in equal intervals of time. At this condition, that's velocity known as constant velocity. And here we will discuss this case when the velocity of an object is constant. It means equal intervals of time variations, and there is no effect on the velocity of an object. Velocity of an object remains same, constant, there is no variation. At this condition, we will draw a graph, x-axis and y-axis. We will denote the time along x-axis and velocity along y-axis. When with the passage of time there is no variation in velocity, velocity never increase and never decrease, it will be same and remain constant. At this condition is drawn as like this, and this is velocity and time. velocity and time, and this shaded area is denote the distance covered by a body in a time, and according to the equation S is equal to Vt, S डिस्टेंस कवर्ड है, V velocity है, T टाइम है, and this conditions there is no variation in velocity with respect to time. This is a constant type of velocity. Then S is equal to Vt. This is known as the area of an area. Area is height multiplied by width. Yeah, length. At this height V multiplied by T, this equation and this is equal to the, both equation are same. That's mean area is covered by an object with the condition of velocity constant. This is first case when the velocity of an object is constant and area is covered by a body, the distance covered by a body is equal to the area Vtk. And second condition, when velocity of an object is uniform, at this condition we will draw a graph, time along x-axis, velocity along y-axis. At this condition, with the passage of time, in same interval of time, same amount of velocity varies. For example, 1 second, 2 second, 3 second, 4 second, here 10 meter per second, 20 meter per second, 30 meter per second and 40 meter per second. Same amount of velocity varies in same interval of time. Straight line and this shaded area denote the distance covered by a body in a time interval with uniform velocity. This is denoted as triangle. When an object is moved with uniform velocity and with the passage of time, the straight line between the time and velocity shows the uniformly variation of velocity with respect to time. In same interval of time, same amount of velocity, same velocity values is varies. For example, in first second, velocity of an object 10 meter per second, and with other 1 second mean it's reach 2 second, the velocity of an object reach 20 meter per second, at 3 second with 30 meter per second, at 4 second with 40 meter per second. Every 1 second velocity increase 10 meter per second mean its uniformity changes in velocity. A variation of velocity is uniform. At this condition, this graph is, and s is equal to vt. This is the equation for distance, and at this condition we find average at this point and this point. At starting point the velocity of an object is 0, and at highest or final point the velocity of an object is v. Then we find average velocity 0 plus v divided by 2 is equal to half v. And average distance s is equal to average velocity half vt, and this is equal to the area of triangle. Area of triangle half height multiplied by length, and area of triangle is equal to half vt, and this equation shows s is equal to half vt. And this shaded area triangle distance covered by an object with uniform velocity. It's mean when object is moved with uniform velocity and it covered a distance half vt is equal to the area of a triangle. This is a second case when velocity of an object is uniform. And next is a third case when velocity of an object is increases. When velocity of an object is increases. And when the velocity of an object is increases, the acceleration also increases, because acceleration produced because of the variation of velocity with respect to time. Change in velocity with respect to time is called acceleration. When velocity of an object is increases, it means acceleration of an object also increases. And at this condition, time along x-axis and velocity along y-axis, when velocity of an object is increases, it's mean at first second the velocity of an object is 10 meter per second, and next 1 second the velocity of an object reaches to 15 meter per second, and at third second, next second the velocity of an object reaches 35 meter per second, and next second velocity of an object reaches 55 meter per second. It's mean every 1 second velocity changes 5 meter, 10 meter, 15 meter increases. At this stage the graph at first second velocity reaches here, and second increases, and this like this, and this is at this point we will find out the instantaneous acceleration. This is shows this point A is shows as instantaneous acceleration. According to this point, when an object is moving with increases velocity, the variation in velocity with time is v is increases, and the velocity and the graph shows a curved path like this. This is the third condition of velocity when velocity of an object is increases. At the, and at next point, fourth case, this is a acceleration, increases acceleration or positive acceleration, and next second when acceleration is negative, and in other words deceleration. At deceleration points, a stage, the velocity of an object decreases with respect to time. At first second, velocity of an object increases 10 meter, decreases 10 meter per second, and next 1 second decreases 15 meter per second, and next 1 second decreases 25 meter per second. That type of velocity is known as negative acceleration or deceleration. When velocity of an object is decreases, at this point the graph rotate. When we rotate it here at this point makes at here, when we rotate it, then it's give the graph of velocity of an object, variation of velocity of an object when velocity is decreases. Like this. This is an x-axis time and velocity along y-axis. Velocity at 50 meter per second. At this condition, when object is moving with highest velocity at 50 meter per second, and when a car or any other vehicles moves with 50 meter per second, and then suddenly brake applied on car, at this stage the velocity of an object is decreases with respect to time. At this condition, velocity 50 meter per second, at 1 second it's decreased 1 second 10 meter per second, at next 1 second 15 meter per second, and then like this time increases and velocity decreases. And this is a curved path. This curved path in negative side shows that the variation of velocity with respect to time. These are four main cases when the variation of velocity with respect to time, which we denote in the form of graph, which known as velocity time graph. I hope you all understand these graphs, and then we will meet in next lecture. Assalamu alaikum. Allah Hafiz.